Hey guys, so in this video, I'm going to discuss Qubic's new scientific paper discussing about the AGI journey that they're going on. And this scientific paper was created by Dr. Jose Sanchez and David Vivanco. So I'm just going to discuss my thoughts on it and let you know what I think about it. So let's get into it. So yeah, guys, about a week ago, or a little bit over a week ago, I think it actually was Christmas Eve, this document was released. It's a scientific paper. It's been submitted for peer review, and it's an interesting paper. It's like huge, I think it's the guts of 58 page, something in here. Well referenced, very interesting. Gotta be honest on my thoughts on it. So firstly, I'm in no position to review big scientific papers. I can only just give, and I didn't read this in mad detail. I more scan read it. But my main thoughts were I was kind of scan reading it and seeing, what could I pick out? And the main really interesting thing that I picked out was just this part on neural processing efficiency across AI architectures. And we can just see here, Qubic or Aigarth in terms of computational cost. It's got the lowest computational cost according to this paper, and of course it will be peer reviewed, which is good. In terms of energy efficiency, the best energy efficiency, the best in terms of adaptability, and the best in terms of resource utilization. Of course, I don't know, are they comparing every different type of AI architecture, but they seem to be saying that they are in this document. So that I thought was the most positive thing that I read in the paper. Other than that, I thought the paper appeared to be an interesting read, but it more read like a college project, and it wasn't talking, in my opinion, enough about Aigarth and specifics to Aigarth. And the reason for that is pretty clear. The reason it's talking that way is because Aigarth is only at the very, very beginning stage where they've started this intelligent tissue stage, and now they're going to start training the AI. And this is just the initial paper on it, kind of the foundational paper that we should be looking back on in the future. And people see this foundational paper and they say, oh yeah, that was talking about the roots of Aigarth and the AI. And then over the next year, we'll get the next paper, and the next paper hopefully will show signs of intelligence. But the important thing is here, there's no results in this paper. There's nothing in this paper that's like, oh yeah, we did this with the AI that we've built, and it's had this level of success or this result that showed intelligence. And to me, that was kind of unexciting. It's more just talking about previous research that's been done and what they're basing the research on and what Aigarth's based on. So it's an interesting read, or appears to be. As I said, I didn't, I more scan read it, but for me, it just read like something that you would do in college. A really, really great college paper. Like, don't get me wrong, but I just mean a paper that hasn't shown, this huge progress, and we're gonna have to wait more. So I know that's kind of a disappointing overview, but I was really looking forward to seeing this paper. I don't know what I expected. I was hoping there was going to be something about the first signs of intelligence coming out of Aigarth. What this paper shows to me is that Qubic appear to be following a correct approach compared to what ChatGPT and a lot of these other huge companies, the models they're following. The only thing is we don't know how well they're following this approach. But I just think someone will use this exact approach that Qubic and Aigarth are using, and they will develop AGI overall. Guys, what I'm going to do is to give you a full breakdown of everything that's in the paper. I'm going to use this really cool tool. You've probably heard of it before. I think it's called Google Notebook, or LM Notebook. It's a tool by Google. And basically what you do is you upload this paper into this notebook, and it creates a podcast for you, an AI podcast, and they discuss the paper, and they'll just pick out the main points from the paper. As I said, I'd love to, if there was more interesting stuff in it, I'd cover it, but I think in that podcast you're going to see the most interesting points out of the paper. personally, I don't even know if they're that interesting yet. But it's it's cool to hear that tool in action anyway, and you'll hear some cool things. I've got some better, more positive videos coming up about Qubic and what's really happening right now with the Qubic network. I'm going to have them coming soon. But right now in the AGI element, not a lot to report, to be honest. So let's listen to that little podcast that the LM notebook produced, and just listen to how cool of a tool this is. If you haven't heard of it before, it's so cool.
Welcome back, everybody, for another deep dive. This time, we're going to be tackling something, I think, pretty mind-blowing, artificial intelligence.
Yeah.
But not the kind you're probably used to hearing about.
Yeah.
We're going way beyond those algorithms that are, curating your social media feeds and all that.
Exactly. This deep dive is inspired by a research paper you sent over.
Okay.
And it's titled Qubic AGI Journey, Human and Artificial Intelligence Toward an AGI with Aigarth.
Ooh.
So it's all about a new approach that aims to mirror and maybe even surpass the very essence of human intelligence.
Okay, so before we get into how this company, Qubic, is aiming to pull this off, the paper starts with something really fundamental.
Mm-hmm.
The G factor.
Yes.
Now, I kind of get it. It's, general intelligence. It's like the engine driving how we learn and solve problems. But I'm curious about the nuances here. What exactly are we talking about when we say G factor?
Yeah, so it's not just about, like, acing an IQ test. It's the underlying potential that affects so much of our lives.
Okay.
And what's fascinating is that this paper connects the G factor to Aigarth's unique CPU-based approach, suggesting their design might be tapping into something fundamental about how our brains work.
Oh, that's already making me rethink what intelligence even means.
Yeah.
But to really grasp this connection, I think we need to kind of unpack what the paper says about G.
Okay.
Now, I know it's influenced by both our genes and our environment, but how does that actually play out in real life? Like, how powerful is this G factor?
So the paper highlights this study called the Dunedin study, and they followed over 1,000 people for decades.
Wow.
And what's striking is that their childhood G scores predicted much more than just academic success.
Oh, wow.
They correlated with adult health, financial stability, even relationship outcomes.
Wow, that's a lot more than just being book smart.
Yeah.
Does the paper say anything about why G has such a powerful impact on seemingly unrelated areas of life?
Yeah, here's where it gets really interesting. The paper delves into the biological underpinnings of G, suggesting it's linked to the brain's efficiency in processing information and forming neural connections. And this, they argue, connects directly to how Aigarth is structured.
Okay, I'm starting to see that link to the CPU focus.
Right.
But before we jump into that, I think we need to explore how our brains actually use this G factor. Now, the paper talks about the brain as a prediction machine.
Yes.
Is that a key idea here?
Absolutely. It's not just about reacting to the world. It's about constantly building models to predict what will happen next.
Okay.
Everything from, like, recognizing a friend's face to navigating a busy street relies on our brains, generating and testing predictions.
So it's like my brain is always running simulations, trying to stay one step ahead of reality.
That's a great way to put it.
And then if the prediction is wrong, I get surprised. And that's how I learn.
Exactly.
Yeah.
And this prediction-driven model is central to how the paper sees human intelligence working. What's even more intriguing is how they connect this concept to the challenges of creating truly intelligent AI.
So are they saying that our brain's ability to predict is something that's been difficult to replicate in machines?
Exactly. Most AI today excels at specific tasks, like what's called narrow AI, think like self-driving cars or chess programs.
Right.
But they struggle with the flexibility and adaptability that comes from constantly generating and updating predictions about a complex world.
It makes those narrow AIs seem almost robotic.
Yeah.
Even if they're incredible at what they do.
Yeah.
So how does understanding the brain as a prediction machine help us to create AI that's more, human-like?
That's the million-dollar question.
Yeah.
And it's where this paper takes a turn, introducing us to Qubic and their potentially revolutionary approach with Aigarth. Before we delve into the specifics of Aigarth, it's worth noting that this paper doesn't shy away from the ambition of their goal.
Creating what they call true AI. Not just mimicking human intelligence, but potentially surpassing it.
True AI, it sounds almost like something out of science fiction.
Yeah.
But what exactly do they mean by that? What would set this kind of AI apart from what we have today?
Well, the paper outlines several key characteristics.
Okay.
First, true AI would possess general problem-solving abilities.
Okay.
Capable of tackling diverse challenges across different domains, not just excelling in a narrow, predefined area.
So instead of an AI that's like a chess master or a medical diagnosis whiz, it would be able to do both.
Exactly.
And much more, adapting its intelligence to any problem.
Exactly. It's about moving beyond task-specific expertise to a more fluid, adaptable intelligence.
Okay.
More like our own.
Got it.
And this ties in with another key characteristic they highlight.
Okay.
Continuous learning and adaptation even during operation without needing explicit reprogramming for every new situation.
That's incredible. It means the AI wouldn't be limited by its initial programming.
It could constantly evolve and improve based on its experiences, almost like a human learning throughout their life.
Precisely. And this continuous learning wouldn't just be about accumulating knowledge,
Right.
but also about refining its own learning processes. Becoming better at getting better, so to speak.
It's like it would not only get smarter, but also wiser, learning how to learn more effectively.
Yeah.
But there's another characteristic that really caught my eye. Creativity.
Yes.
The paper suggests true AI wouldn't just be good at problem solving.
Right.
You'd be able to generate novel ideas, maybe even artistic expressions. Isn't that pushing the boundaries of what we typically think machines can do?
It definitely challenges our assumptions.
Yeah.
But the paper argues that creativity is an emergent property of sufficiently complex systems,
Okay.
not a uniquely human trait. They believe that by creating the right conditions, AI could exhibit genuine creativity, maybe even surpassing our own.
That's a mind-blowing idea.
Yeah.
So instead of seeing creativity as this like magical human spark,
Right.
they're saying it's a natural outcome of a certain level of intelligence, regardless of whether that intelligence resides in a carbon-based brain or a silicon one.
Exactly.
Okay.
But there's more.
Okay.
The paper also emphasizes the need for true AI to be able to reason about abstract concepts and connect those concepts to real-world experiences just as humans do.
I'm starting to see a pattern here.
Yeah.
All these characteristics seem to point back to the ways in which human intelligence operates.
Yeah.
Are they essentially saying that to create true AI, we first need to deeply understand our own minds?
I think that's a key takeaway from this paper.
Okay.
They argue that replicating human-level intelligence requires understanding not just the what of our abilities,
Right.
but the how,
Okay.
the underlying mechanisms that make those abilities possible.
So it's not just about building a machine that can like pass a Turing test,
Right.
but one that genuinely thinks and learns and creates in a way that's analogous to our own minds.
That's a great way to put it. And perhaps the most intriguing and maybe controversial characteristic they propose is the potential for emergent properties like self-awareness and consciousness.
Okay, now we're really getting into the philosophical depths.
Yeah.
Can a machine truly be self-aware, conscious?
Yeah.
Aren't those qualities inherently tied to our biological existence, to our lived experiences as humans?
It's a question that has puzzled philosophers and scientists for ages.
Right.
And this paper doesn't pretend to have a definitive answer. What's interesting is their approach.
Okay.
They're not aiming to program self-awareness or consciousness directly.
Yeah.
They believe these qualities could emerge naturally as a result of the system's complexity and its ability to learn and adapt.
So it's less about coding consciousness into the AI and more about creating the conditions where consciousness might spontaneously arise.
Exactly.
Okay.
It's a bold idea, and whether it's achievable remains to be seen. But it speaks to the paper's underlying premise, that true AI won't be something we simply engineer. It's something that will emerge from the complex interplay of algorithms, data, and the environment itself.
It's almost like they're saying, let's set the stage, provide the building blocks, and then step back and allow intelligence to unfold on its own.
Exactly.
But this all sounds incredibly ambitious. What are the concrete steps that Qubic is taking to turn this vision of true AI into a reality? We've covered some pretty mind-bending concepts about true AI.
Yeah.
But let's get practical.
Okay.
How is Qubic actually building this thing? Now, the paper dives deep into something called a Qubic Aigarth scoring algorithm.
Right.
What's that all about?
This algorithm is key to Aigarth's unique approach.
Okay.
It takes those lofty ideas about the G-factor, prediction, and even ternary computing, and puts them into a measurable framework.
Okay.
Think of it as the driving force behind Aigarth's evolution.
Okay, so it's not just a way to measure intelligence.
Right.
It's actually shaping how the AI develops.
Yeah.
Okay, I'm really curious to hear how that works.
So it starts with a network of those ternary neurons we talked about, capable of true, false, or unknown states.
Okay.
Then a specific pattern encoded in these states is fed into the network as a challenge.
So it's like giving the AI a complex puzzle to solve.
Yes, exactly.
And the way it solves the puzzle reveals something about its intelligence.
Exactly. But here's the twist.
Okay.
The connections between those neurons aren't pre-programmed.
Yeah.
Aigarth generates them randomly using cryptographic techniques to ensure it's both verifiable and reproducible.
Well, random connections.
Yeah.
Wouldn't that make the network unpredictable? Maybe even chaotic? How can you build intelligence on randomness?
That's the beauty of it.
Okay.
This randomness mirrors the way our own brains develop, with connections forming and reforming throughout our lives.
Okay.
It's a core principle of Aigarth to create the conditions for intelligence to emerge organically,
Right.
rather than trying to force it into a predefined structure.
So they're not dictating how the AI should think. They're creating an environment where it can discover its own way of thinking.
Exactly.
That's a pretty radical departure from traditional AI, isn't it?
Absolutely, and this ties back to the G-factor discussion.
Okay.
The paper argues that this randomness, combined with Aigarth's CPU-based approach, might be mimicking something fundamental about how our brains process information
Right.
and form those all-important neural connections.
Okay, I'm starting to see how all these pieces fit together.
Yeah.
But how does this random network actually solve the puzzle? And how does the algorithm score its performance?
Once the network is set up, each neuron starts processing the input, updating its state based on its neighbors.
Okay.
This happens asynchronously, not in lockstep,
Right.
much like the complex interactions happening in our own brains.
So it's not a simple linear process.
Right.
It's more like a chaotic dance of neurons, each responding to its own local environment.
That's a great way to visualize it.
Okay.
After a set time, the algorithm compares the network's output to the original pattern. The closer the match, the higher the score.
So it's a measure of how well the network was able to understand and represent the information contained in the pattern.
Exactly.
But you said earlier that this score isn't just a static measurement.
Right.
It actually guides the AI's evolution.
Yes.
How does that work?
Aigarth runs this process repeatedly each time, with slightly different parameters or network variations.
Okay.
Think of it as a massive tournament with thousands of AI contenders competing to solve the puzzle.
And those that score well are more likely to survive and reproduce, passing on their successful traits to the next generation.
Precisely. It's digital natural selection in action.
Wow.
The higher scoring networks are bred with each other.
Okay.
Their structures combined and tweaked, creating new variations for the next round of the tournament.
It's like they're accelerating evolution,
Yeah.
compressing millions of years of natural selection into a rapid, iterative process.
And this evolution isn't just happening at the level of individual connections. The very architecture of the network, the number of layers, the types of connections is also evolving,
Right.
constantly being reshaped by the scoring algorithm.
So it's not about finding one perfect design.
Right.
It's about creating a system that can constantly discover and optimize new designs,
Exactly.
pushing the boundaries of what we even consider intelligent architecture.
That's the power of this approach.
Yeah.
It embraces the unknown, allowing for solutions to emerge that we, with our limited human perspective,
Right.
might never have imagined.
But all this evolution, all this experimentation, it must require immense computational power.
Right. Yeah.
How can they possibly manage that?
This is where Quabic's focus on CPUs really shines.
Okay.
By leveraging the power of distributed computing,
Okay.
harnessing the collective processing power of countless CPUs around the world.
Got it.
They've created a system that's both scalable and accessible.
So instead of relying on like expensive specialized hardware, they're democratizing AI development using readily available resources to create something truly groundbreaking.
Exactly.
And this distributed approach also aligns with their vision of a more decentralized future for AI, one where development and control aren't concentrated in the hands of a few powerful entities.
Yeah.
Well, we've covered a lot of ground today.
We have.
From the fundamentals of human intelligence to the intricate workings of Aigarth's evolutionary algorithm.
Yeah.
It feels like we've just scratched the surface of this incredibly complex and rapidly evolving field.
It really is.
As we wrap up this deep dive, what's the one key takeaway you'd want our listener to remember?
I'd say this. Aigarth is a reminder that the quest for artificial intelligence is as much about understanding ourselves as it is about building machines. By exploring the mysteries of our own minds, by questioning our assumptions about intelligence and consciousness, we open up possibilities that extend far beyond the realm of technology.
Beautifully put. It's not just about creating a smarter world. It's about expanding our understanding of what smart even means.
Exactly.
And who knows, maybe in trying to build machines that think, we'll end up learning something profound about what it means to be human.
Yeah.
That's a perfect note to end on. We hope you've enjoyed this deep dive into the world of AI and Quibic's groundbreaking work with Aigarth. Keep those minds engaged, and we'll see you on the next deep dive.
Until next time.